Okay, in this section we're going to talk about inverse functions, which is another preliminary topic to logarithmic functions, which is where section 5.4 begins. Definition: if f is a function, then the inverse of f receives as input a number, which we're going to call f of x. It manipulates it and outputs the value x. Okay, so that is the exact opposite of what an original function does. We know that with an original function, the input values are the x values, and the output values are the f of x values. Okay, so let's take a look at an example here. For example, suppose that we have a group of people and the corresponding birthdays. What is the inverse of f? Well, I just simply switch the two sides. So the birthdays are the input and the people, their names, are the output. Now the inverse is a function f, and notice how f of x does not have an inverse here, or it has an inverse, but it is not a function. Okay, because I got May 3rd going to Andy and Nate. Okay, of course we can only have one output value going, not two different output values. So the for another example, suppose that I got a set of points. 5, -2, 1, 4, 0, 0, and -3, -27. Well, the x values are going to be the y values, and the y values are going to be the x values. So the inverse here is -2, 5, 4, 1, 0, 0, and -27, -3. You want to write that as a set of points, and so that would be the inverse of f. Now, the inverse of f is a function, okay, for this one. Definition: if the inverse of f is a function, then f is called 1-to-1. Okay, let's go back to these first two examples here. Here's my function. I got f of x. And notice how I do have a function, even though Andy and Nate share the same birthday. I do have a function. Okay? Since for each input there's only one output. Everybody has exactly one birthday. Okay? It's impossible for somebody to have two different birthdays. So I do have a function, but the inverse is not a function. Okay? Because I get an input going to two different outputs. Not a function. So while I want to state f of x, I do not want to state f inverse of x. Now over here, in this example, here's f of x. Okay, and here's f inverse of x. F inverse, notice how that's also a function. Okay, so it's okay for me to use the inverse function notation. We call this f inverse of f of x. And I don't want to do that up here. Okay. There's also the horizontal line test. Now we looked at the vertical line test for studying whether a graph is a function. The horizontal line test says that if every horizontal line intersects the graph of a function f and at most one point, then the function is 1-to-1. Okay, so f of x equal x squared. I've got the axes labeled. Then the number lines aren't especially important for this example. So I've got those unlabeled. This is not 1-to-1 because it fails the horizontal line test. Okay, it's a function, but it's not a 1-to-1 function. Okay, because it fails the horizontal line test. Now over here, I've got f of x equal x cubed. And this will pass the horizontal line test. So, I can use f inverse if I want to. Okay, 1-to-1. This is not one-to-one. As far as inverse function notation goes, use f inverse of x. Now be careful, f inverse is a symbol for the inverse function. The -1 is not an exponent. That is, f inverse does not mean the reciprocal of f. That would be f to the -1 power. F to the -1 power is the same as 1 over f. And that's not at all what we're saying here in this notation. So f inverse of x, the -1, meaning word inverse, is just strictly a notational thing to represent the word inverse. Okay. Let's let f be 1-to-1. What does that mean? Well, the inverse of f is a function. Okay, so g is the inverse of f if f of g of x is x and g of f of x is x. Okay, so I check if two functions are inverse of each other through function composition. Now that's what I learned in section 5.1. Okay, and I got to get x on both of those. So, for example, let's verify that the inverse of f of x is, which is 2x plus 3, is f inverse of x equals 1/2 the quantity x minus 3. Okay, well, I want us to verify that these two functions are inverse of each other. So I got to compute f of f inverse of x and f inverse of f of x, and check that I get x on both of those. F of f inverse of x gives me f of 1/2 times x minus 3. Okay, so I replace that with 1/2 times x minus 3, and I've done that. Now the 2's are going to cancel there, leaving me with x minus 3 plus 3, so x minus 3 plus 3 gives me just x. F inverse of f of x is f inverse of f of x is 2x plus 3. Okay, 1/2 times 2x plus 3 minus 3. Okay, well the 3's cancel there. 1/2 times 2x, the 2's cancel, that gives me x. So since both sides calculated to be just x, that is a verification to me saying that indeed these two functions are inverse of each other. Okay? Another problem, let's find the inverse of f, the domain of f, and the range of f. Okay, so suppose f of x is this curve here passing through points -2, 1, 1, 0, -1, 0, and 2, 1. Okay, and it's going to start and stop at -2, -1, and 2, 1. Okay, the inverse, I would flip x and y and plot those new points. Okay, so let me do that. Here's 1, 2. Here's 0, -1. And here's -1, -2. Okay, and then I would draw these two line segments. Now notice how this graph is symmetric about the line y equals x. That will always happen. Whenever you graph a function and its inverse, they are always symmetric with the line y equals x. Okay, so now another thing about this is notice how I'm using the inverse function notation, f inverse of x. Okay, I'm not just leaving this as an equation in terms of y and x, which is totally different. In other words, f is 1-to-1. Okay, now I can use the horizontal line test if I want to, or the inverse is a function. So I could use the vertical line test on the inverse. The domain and the range of f. Okay, the domain of f is the curve in black here. Domain means I'm talking about x. So -2 to 2, including -2 and including 2 would be the domain. And the range of f, okay, now I'm talking about y. -1 to 1. Now the range of f is always the same as the domain of the inverse. Okay, so domain means I'm talking about x now again. Inverse means I'm talking about this curve here in red. Well, the conditions on x are that x is between 1 and -1, including those endpoints. Okay, so that's the exact same set as the original function there that I've got for the range of f. Okay, and it will always happen such that the range of a function and the domain of the inverse are always the same set. Okay, so sometimes it's easier for us to state the domain of the inverse, as opposed to graphing and looking at a graph and stating the range of the function. Okay. Another example, suppose that f of x is 2x plus 3. Let's change y to f of x. Y and f of x mean the same thing, so there's no harm with doing that. Okay, y equals 2x plus 3. Let's compute the inverse. Well, inverse is all about switching x and y. So where I see y, I'm going to write x. Where I see x, I'm going to write y. And x is equal to 2y plus 3. Subtract 3 and divide by 2. Y is equal to 1/2 times x minus 3. Okay, now that is an inverse function. So f inverse of x equals 1/2 times the quantity x minus 3. Now we've already done this one. How do I know that this is right? Well, I've already done this one. See, this is the check procedure, which is done typically after you calculate the inverse. Okay, so this would be a rare time, I guess, where we checked our answer before we got our answer type thing. So in other words, I know that this is the right answer because I've already checked this. Okay, the domain of f is all real numbers. F is a linear function. The domain is all real numbers. The range of f, the range of f is the same as the domain of the inverse. The domain of the inverse is 1/2 x minus 3/2. That's another line. And so all real numbers. Okay, we've already verified this right by checking by checking it earlier. Okay. Where are we at here? Next one, f of x equals -x squared plus 2. Okay, well, y is equal to x squared, -x squared plus 2. Y and f of x mean the same thing. So now let's compute the inverse. Let's switch x and y. X is equal to -y squared plus 2. Okay, well, I subtract 2 and multiply by -1 on both sides. So y squared is equal to 2 minus x. Y is equal to plus or minus the square root of 2 minus x. Okay, the plus and minus there means that the inverse is not a function. F is not 1 to 1, so there is no inverse function. No inverse function. There is an inverse, we just computed it, but it's not a function. Okay, of course, for a function to happen, we can only have one y value for each x, not a plus y and a minus y for each x. Okay, and that's what I got going on here. The domain of f is a quadratic. This is a parabola that's shifted up, that's reflected about the x-axis and then shifted up 2 units. The domain is going to be all real numbers, and the range of f is the set of all y such that y is less than or equal to 2. So if I am looking at a parabola that is starting off with y equal to x squared, and I reflect about x, I've got a parabola facing downward, and then I'm going to shift up 2 units. Well, in terms of the y values, all I've done is I've shifted a parabola up 2 units. That's facing down. So y is going to be less than or equal to 2. Okay? For example, suppose that f of x is equal to 1 over x plus 2. Well, let's call that y. Y is equal to 1 over x plus 2. X is equal to 1 over y plus 2. So let me multiply both sides by y plus 2. X times y plus 2 times x equals 1. And I'm solving this for y. So let's subtract 2x and then divide by x. Y is equal to 1 minus 2x all over x. Okay, don't have any plus minus going on. So I can say f inverse of x equals 1 minus 2x all over x. Okay, there's no harm with that. The inverse of a function is also a function. Now, how do I know that I'm right? Well, I got to check. Check that f of f inverse of x gives me x, and f inverse of f of x gives me x. Well, here's the check procedure real quick. F of f inverse of x. F inverse is what I've computed here. Okay, I got to replace that in for x, wherever you see an x. So 1 over 1 minus 2x over x plus 2. Okay, I've got that. 2 is the same as 2x over x. And so 1 minus 2x plus 2x over x, negative 2x plus 2x is 0. 1 over x is the same as x. Okay, so we're all good there. Now, if we're all good there, usually, it's safe to assume that f inverse of f of x is also going to be x, but I've checked that just to be sure. F inverse of 1 over x plus 2 means wherever I see an x in the inverse, there's 2 of them, I got to replace those with 1 over x plus 2. Well, let's see here. So 1 minus 2 times 1 over x plus 2 divided by 1 divided by x plus 2. X plus 2 over x plus 2, I've changed to 1, minus 2 divided by x plus 2, divided by 1 over x plus 2. So I've got get a single fraction there in the numerator. X plus 2 minus 2 gives me x, and x divided by x plus 2 divided by 1 over x plus 2. Let's flip the 1 over x plus 2, and the x plus 2's will cancel. That gives you just x. Okay, so I know I've got the right answer here, which means I can go ahead and circle this. The domain of f. Okay, well I can go back to section 4.4 and 4.5 for a moment and recall what I know about vertical asymptotes. X can't be negative 2, right? So the set of all x such that x is not equal to negative 2. And the range of f, well, I can recall what I know about horizontal asymptotes. The degree of the top is less than the degree of the bottom. The degree of the top is a degree 0 polynomial divided by degree 1 polynomial. So whenever that's the case, y equals 0 is a horizontal asymptote. So the reason why we do not cross the graph of 1 over x plus 2 is because there's an asymptote there at y equals 0. Okay, a set of all y such that y is not equal to 0 would be the range of f. All right, the homework is on page 274, and so be sure to look at the problems there for me.